Hi guys, today we're going to look at some neat tide tidal bores in Tidal River. But before we get into that, you may be wondering, what on earth is a neap tide and what's a tidal bore? Well, let's explain both of these before we get back into the tidal bore footage. Okay, to explain neap tides, we're going to use this diagram, with the green circle as the Earth, the yellow one as the Sun, and the grey one as the Moon. To show you how tides work more clearly, I have greatly exaggerated the effect of the tide. The effect of the sun on the tide is called a solar tide, and the effect of the moon on the tide is called a lunar tide. On new moons or full moons, when the sun and the moon and the earth are roughly aligned, the effects of the sun and moon on the tide add up, leading to very large and fast tides. When this happens, it is called a spring tide. But as the moon goes out of line with the sun, its effect on the tide does too. When they pull in different directions, the two tides cancel each other out, resulting in smaller, less drastic tides. This is called a neap tide. Now that you know what spring and neap tides are and how they work, let's explain tidal bores. To start, let's look in an aerial view of Tidal River, where this tidal bore was filmed. Notice the funnel-like shape where the river meets the sea? This funnels all the tide from the bay into the river. When the tide from the bay gets funneled into the slightly smaller space of the river, it builds up into a surge. This is why only some rivers in the world have tidal bores. They have to be a specific shape. But even with this effect, shouldn't it be more of a surge than a wave? Well, that's where the second effect comes into play. As the tide builds up, the river pushes it back. This doesn't stop it completely, but slows it down. More humps of tide build up behind it, with the ones towards the front being affected by the river more and therefore moving slower, and the ones towards the back being affected less and moving faster. The humps move forward at their different speeds and eventually merge into one where the river drops off to the ocean. When they merge, they create a large enough wave that it overcomes the force of the river. Since the ocean is deeper than the river, the wave gets pushed up higher as it travels up the river. This gets pushed up and creates a tidal bore. One large tidal bore, or a few consecutive smaller ones, as is the case with Tidal River, eventually levels out the tide. These two effects combined create tidal bores. Some rivers in the world have huge tidal bores, but the ones at Tidal River are usually 1.5 meters maximum on a spring tide, but it is still a sight to behold. Tidal River is also special in another way. While other tidal bores happen a few times a year under the right conditions, the ones at Tidal River happen every day. Okay, let's jump into the footage.